Hello guys, this is the last part of Career Week Questionnaire time series case study. So first of all, I'm explaining the assignment problem statement. So assignment problem was there was a supermart sales giant and we had to forecast the sales and quantity based upon the topmost two most profitable and consistent sectors out of the 7 markets and 3 segments. So for that we divided our data set into test and validation data sets. In test data set we had kept 42 in trained data set, we had kept 42 data points because data was given from January 2011 to December 2014. So there were 4 years of data, that is of 48 months. So we divided it into 48 data points, and what we did, we built our model based on classical decomposition method first, and then based on auto ARIMA model. So what we did in local decomposition classical decomposition method, we first predicted the global predictors using a linear regression, and then after predicting the global predictors we subtracted it from the original time series. Then after subtracting it, we got uh, the subtracted value, and we checked that if it is stationary or not. If it is not stationary, then we again predicted the local predictors, and then we again checked for the residuals by using Dickey-Fuller test or KPSS test. If it is stationary, then obviously it is a white noise. For that we also used the ACF or PACF graphs, and then again we validated our result on the remaining 6 data points that we had kept aside for validating our model. And in the auto ARIMA model, we passed the time series for the 42 data points. It generated the ARMA fit, and then we can compare the MAP values of these two methods, like classical decomposition and auto ARIMA method. So the one which is having low MAP value will be more accurate, so according to that we made the selection out of which we should be predicting our results. Now what other methods do you know that can be used for modeling? So time series, other methods have not been covered in the course, but we have been taught some other forecasting methods like other smoothing techniques which can be used for making forecasting, like Nave's method, in which previous value is equal to current value, moving average method, in which we can take the average of past 3 or n data points, simple exponential method. Which methods are used to check whether a time series is white noise? We can use Dickey-Fuller test or KPSS test as told earlier. For Dickey-Fuller test, the null hypothesis is that if the null hypothesis is the series is not stationary, and for KPSS test the null hypothesis is that series is stationary. So if we have a low p-value less than or equal to 0.05, then in the Dickey-Fuller test we can reject the null hypothesis and say that the series is stationary, or vice versa in KPSS test. What is white noise? White noise is something in which there is no pattern or seasonality in it. So and we can use smoothing techniques to remove it from the time series data. That's why smoothing is important. Why do you check for what is a stationary time series? A stationary time series is something which does not change its value according to time, or in simple words, it can be said that its average remains constant over time, over different time intervals. uh, what is a PACF plot? PACF is partial autocorrelation function, which gives the value of the uh, difference between the different uh, time series values at different time intervals. Whereas the autocorrelation function simply provides the lag values at which the time series will replicate itself. Uh, their uses are to predict the time series if it is stationary or not. Uh, which parameters are generally used to evaluate the fit of a time series model? Yeah, uh, AIC and BIC are the two parameters that can be used to uh, evaluate the fit of a time series. If the AIC is high, then obviously that time series model is not good, and if the BIC is high, then that time series is good. uh, MAP MAP should be interpreted as if mean average percentage error. So it is very good if it is very low. As low it gets, it is that good, and as high it gets, it is very bad. So what are the advantages and disadvantages of using MAP? We can compare our models using their MAP values. Which parameters are generally used to evaluate how should MAP be interpreted? Yeah, that's done. What are the advantages and disadvantages of using MAP as opposed to, yeah, uh, R square value cannot be used. It is definitely one of the parameters, but not the guaranteed parameter. That's why we always look for MAP value only, because R square value depends on some other factors as well, whereas MAP gives us the error percentage. What is the mean average error percentage? So that's why we take MAP into account while deciding which model is good. That's all. Thank you guys.